All right, so we're coming back. We kind of had our intro to logarithms yesterday, and now we're going to get into what those graphs are going to look like. So in case you guys forgot, I told you kind of when I began the first day, exponential and logarithmic functions are inverses of each other. Okay? So same way quadratic and square root, cube and cube root, all that. So you have exponentials and logarithms are inverses of each other. So the way that you can generate their graphs, if you're given a table, is that you can just switch your x and y. So this is our exponential graph, all right, for 2 to the x. We talked about 2 to the x in our last unit. So if I started to flip, now my x's are my y's. So 0.25, 0.5, 1, 2, 4, and 8. And my x's become my y's. So I've got negative, not negative 1, negative 2, negative 1, 0, 1, 2, and 3. All right, if I were to graph that, so if we started to graph that, my x is 0.25, my y is negative 2. So that's about right here. Then I have 0.5, negative 1. That puts me about right there. 1, 0, 2, 1, 4, 2, and then 8, 3. All right, so you get a graph that's going to end up looking like this. All right, so remember that when you're doing this, they're going to reflect over that y equals x line. So you have that imaginary line that's coming between two inverses that looks like that. And that's what it's getting reflected over top of. All right, so if you folded it right there, you'd hit it on the other side. So what is that going to do with our asymptotes, domain, and range? So when we did exponential, you know that you had a horizontal asymptote right here at that y equals 0. All right, so in our parent function, we had horizontal asymptotes. So this was at y equals 0. When you are transforming, x's and y's flip. So instead of y equals 0 being our asymptote, now we're going to have x equals 0. So now we're going to have a vertical asymptote at x equals 0. All right? Your domain in the last unit, I told you, always, 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 your domain is x is an element of all real numbers. So if our domain was all real numbers for this, that's going to flip here. So now our range is all real numbers. So you're going to get any y value. It goes down forever, it goes up forever. Our range was our asymptote, which was 0 to infinity. And then when we did reflections, things changed around. That means that this is going to come up here, and now our domain is 0 to infinity. So remember yesterday when we were solving, and I told you you would never have negatives inside your logarithm. That's because you can never have negative numbers. So if you see here, these are only all my positive x values. No negative numbers for your x's, unless we start to shift around. All right. So remember, inverses graphically are reflections over the y equals x line. We just talked about that. And then this is going to be really, really important down here. This is going to help you build your tables and things like that. So exponential parent functions are always going to have the point at 0, 1. We talked about that a lot. Anything raised to the 0 power is 1. And then anything raised to the first power is going to be whatever the base you were given was. So like in this case up here, our base was 2. So we had the point 1, 2. So that's 1, b. For your logarithms, because we're flipping x and y, that means you're always going to have the point 1, 0 in your parent function, and you're going to have the point b, 1. So whatever your base is, 1. So this is the point 1, 0, and this is our base, 1. We're going to see what that looks like when we do a couple of examples. So let's flip over and we're going to talk about those transformations again. So the transformations, they're going to follow all the same things. You will see horizontal stretches in this one and horizontal compressions, and it's going to follow this right here. So remember your A value out here in front, that's always going to tell you vertical stretch compressions. If it's negative, that's when you get your reflection over the x-axis. Then inside the parentheses, in your argument, all right, B tells you when you have horizontal stretches and compressions or reflections over the x-axis. Remember, when you do this one, you always think opposite. So if you have like a 2 in there, that's really a horizontal compression by 2, not a horizontal stretch. H, again, inside here, we're always thinking opposite. So anything that happens with x values. And then K at the end, we're going up and down. All right, this note is really important. So in the last unit, anytime we moved up and down, that moved your asymptote. And this unit, anytime we go right and left, that's going to change our vertical asymptote and tell us where that new one is. So I'm going to do 1 in the video. I'm going to leave 2 for class. All right, so you can work on it on your own or you can wait for class. And let's go through and name what these transformations would be. So there is 3 transformations on this first one. So look through it, kind of see if you can determine them, and I'm going to write them down.
Teachers, at this time, if you will please release all track and field athletes, both boys and girls.
So that negative in front, that's telling us we have a reflection. -2, remember where you think opposite, so this is moving us right 2. And then that +4 on the end, that's going to move us up 4. So those are our 3 transformations that are happening. So now we're going to think about what your very basic one would be, all right? You're only going to do 2 points. So your parent function, just like the way we did the tables on the last one, would be log base 2 of x. That is as basic as you can write it, keeping the same base. Your transformation is going to go on the other side. Now remember, in order to do this, you have to write the rule. So let's go through and let's pick what our rules are going to be. Then we can fill in our table. So if I asked you what are the things that are affecting your x value, you would tell me that the only transformation is this. That is the only thing affecting your x value. Remember, it's always opposite of your equation. So that means to go from x to our new x, we're going to do +2. So from parent function to transform, we're going to take whatever it was and we're going to add 2. For our y value, all right, we're reflecting over the x-axis, so that's going to make our y negative, and we're going up 4. So that's what our rules should look like. All right, now the real question, how do I create those parent function points? That's when you want to go back and you want to think about what I talked about on this side. So all parent function logarithmic functions are going to have the point 1, 0, and they're going to have the point b1. You have to have that down. So let's come back here. We're always in our parent function going to have the point 1, 0, and we're always going to have the point b1. So our base here is a 2. So we're going to have the point 2, 1. Now let's transform those numbers, all right? So let's start with our x values. We're taking our x's and we're adding 2. 1 plus 2, that gives me 3. 2 plus 2, that gives me 4. Our y values, we're going to make it negative, and then we're going to add 4. 0, negative 0, still 0. Plus 4, take 1, plug it in. 1 becomes negative 1, plus 4 is going to give us 3. All right, so let's go ahead and let's try to graph it. Let's start by graphing where your vertical asymptote is. So we went right 2, that means we have a new vertical asymptote right here at 2. We went right 2, so it moved over 2. Now let's plot our points. You have the point 3, 4, and you have the point 4, comma 3. So kind of right on top of each other. So you need to think about a logarithm usually looks like this. If we reflected that and flipped it over, it's going to look like this. So it's going to come down your asymptote, and then it's going to slowly move away. So let's talk about what our domain and everything looks like. So our domain, the furthest left it goes is this asymptote, and then it's going towards infinity. Our range, always, 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 all real numbers. And then again, we said our asymptote is at x equals 2, not y equals 2. Do not miss points on that quiz because you put x equals instead of y equals. All right, we're going to save number 2 for tomorrow. And then we're going to do this last question. We're going to do question number 3. Okay. All right, so the last thing is writing equations for the graph. So it says there's no stretches, there's no compressions. The base value of all of these is 2. All right, so you know that you're working with log base 2 of x. That is the parent function that we're using. So the next thing you're going to look at is you're going to try to figure out what your transformations would be. So remember, if you have log base 2, then we're going to take and we're going to kind of look at, first of all, there's no reflection because it's still right on this side. We're still coming across this way. If we look at this negative 4, if we moved over this way, that means that we went left 4. All right. So our asymptote is now at negative 4. That means we went left 4. The only other thing that you're going to need to check for is, did you move up and down? All right. Now, the only way that you can see if you moved up and down is by checking this point that's on your x-intercept. All right. So in this case, you're given this point, and this on question 4, we're given that point, and we're going to kind of check with what happens with that. So normally you have the point 1, comma 0, right? And your parent function, Usually you have the point 1, comma 0 in your parent function. Now this point, instead of it being at 1, comma 0, is now at negative 3, comma 0. So the only thing that happened was we subtracted 4, all right, which was our left 4. Nothing happened to our y value. That means the only thing that's happening here is that we're going left 4. So if we were to write that in our equation, we would say f of x is equal to log base 2, and then opposite in your equation, so x plus 4. That is the time you have to use parentheses because you need to show that the log applies to both. All right, so that's all for today. Again, we'll work on 2 and 4 tomorrow in class, so you can make sure that you check those. And then we'll get on to day 3 tomorrow. All right.